Hello, welcome back. Good morning and have a good Friday, have a good weekend. It's 9:30. It's 9:30. Did wake up a little bit after 7 a.m. and I got up a little bit before 8, so I already made 3 videos. And I have weighed my body weight today. I lost 1.1 kilo. So I did not get back up on 100 kilos, but I have eat like 1 kilos of candy and 3 or 4 bags of chips. So I have to stop do like that. I have to eat some French fries. French fries is potatoes. So that's better eat some French fries 1 or 2 times every week than candy or chips. So I will do that. So let's take some juice to my bed because this will be just another long hot day in my apartment. It'll be like 30 or 30 to 32 degrees like 1 month in my apartment. But the temperature should drop from today. But we have soon as 1st September and autumn. So I had a hot night again. It's probably why I did wake up 7 a.m. because of the heating. Yes, we need to have some juice next to my bed because I have to drink like this every hour. Every hour or more I have to drink a glass of juice. But I did find a bit more PDF, but I have all this PDF. I have it on other reading lists, so I'm not going to make a double reading list. I already have this CPUs. I don't know where I put it there. Oh, I did put it there. That's my American Truck Simulator. So maybe put it down there. Let's put it down there a little bit. No, let's keep it there. Let's put it down there. But I will make a video later about my read list. I spent many hundreds of hours to download. But I did start. I took a break like 2 months because I had a long hot summer and I did start to drive American Truck Simulator and I did start to play this online game Introvia Universe. And I was low on money and I did need to buy external hard drive to get, because this video takes a lot of space, many thousands of gigabytes. This cost 900 Danish kroner, like 120 or $130. Every 2 or 3 months I need to buy one like this, and I need my money for food and pocket money. And I have stopped use my credit cards, so my payment to one of my credit cards can drop. So I cannot buy any more from this credit cards. This MasterCard there had already dropped like $25. My payment to this credit card have dropped 183 Danish kroner. That's like, but now the dollar have raised a lot. $1 is like 7.5. But let's just say 7 Danish kroner is 183 Danish divided 7. Yes, that's $26, around $25. I have $25 more every month from my payment to my payment have dropped to my credit card. And I have another shopping credit on another MasterCard I have put away because that's another debt I have to pay. So I have to buy this external hard drive out of my YouTube money. But my last YouTube money yesterday I did buy this 2 old desktop computers. Because I like to start collect old PC desktop computers to my project, Persily Computer History Museum Denmark. I have to start old PC computer hardware. I actually just made the first Danish version. I have to do it in Danish. I just call it the PC History Museum Denmark, but in Danish. So I need to spend a little bit money on that, but not much now because I have to move out this apartment like next year maybe. So I cannot have 20 or 30 old computers. That would be 200 or 300 kilos of old computers. I cannot do that now. I have to wait to buy a lot to getting to a new place. I know I can stay there for many years. So I still think about what I should do, but now I just have to. I could buy a few more later, but not this month. So, and I have many hundreds PDF I like to read. I already have all these Pentiums on read list there, but I just like to get started. I like to read the Pentium, but then I did start to I do all the other stuff, and then I have to make a new paper. So now we have downloaded this electronic circuits, microcontrollers, vacuum tube computers, vacuum tube transistors, and this is how you do the CPUs. But I have it everything on the read list there. But I just I like to get started. So I download this, I did read this PDF Central Processing Units. That's one will get to my read again list, like the CPU Cache PDF. I have to read again. That is important PDF. Yes, and this camcorder, this old GVC camcorder, the batteries start to get old. So I did find this PDF electronic circuits microcontroller and vacuum tube computers. And what is vacuum tube? But that is 53. That's 50. Some is very big, some is many pages. This is 53, no, to 33 pages. Transistors is 28. And this person, John von Neumann, that's close to 70 pages. So some is very big. So actually all this will take a few days. And this is 20 pages, this Enigma, and this is old IBM CPU. This MOSFET, but I already have, but I have some I have to read again, and I have this supercomputer too. And then we go back to the memory there. And then we try to read what this will take probably the whole weekend just to do this. So, but let's get started. And the speaker on like 58, and I have my door open. I have my door to balcony open because it's always so hot in my apartment. Yes, that's my gamer keyboard. The USB cable is damaged. I need half a minute to do myself ready. In my bed. So I do this because I like to read it myself, and I will have many hundreds of days alone in my apartment, so why not do this? And my computer is too old to play a computer game. I have to check my cell phone. No message. So let's just continue. I have to turn off the light at my bed table to get a little bit juice. So let's get started. And I read this same time the computer voice is reading. I read this. Actually, I need to clean my glasses. I need to go to kitchen. I have some grease. It's like a dirty glass on a window shield on your car. I have to spend, so I'll be back in half a minute. Yes, I'm back.
Electronic circuit. The die from an Intel 8742, an 8-bit microcontroller that includes a CPU, 128 bytes of RAM, 2048 bytes of EPROM, and I/O data on current chip. A circuit built on a printed circuit board, PCB. An electronic circuit is composed of individual electronic components, such as resistors, transistors, capacitors, inductors and diodes, connected by conductive wires or traces through which electric current can flow. It is a type of electrical circuit and to be referred to as electronic, rather than electrical. Generally at least one active component must be present. The combination of components and wires allows various simple and complex operations to be performed. Signals can be amplified, computations can be performed, and data can be moved from one place to another. 1. Circuits can be constructed of discrete components connected by individual pieces of wire. But today it is much more common to create interconnections by photolithographic techniques on a laminated substrate, a printed circuit board or PCB, and solder the components to these interconnections to create a finished circuit. In an integrated circuit or IC, the components and interconnections are formed on the same substrate, typically a semiconductor such as doped silicon or, less commonly, gallium arsenide. 2. An electronic circuit can usually be categorized as an analog circuit, a digital circuit, or a mixed signal circuit, a combination of analog circuits and digital circuits. The most widely used semiconductor device in electronic circuits is the MOSFET, metal oxide semiconductor field effect transistor. 3. Breadboards, perfboards, and strip boards are common for testing new designs. They allow the designer to make quick changes to the circuit during development. Contents: analog circuits, digital circuits, mixed signal circuits. See also references, external links, analog circuits. A circuit diagram representing an analog circuit. In this case, a simple amplifier. Analog electronic circuits are those in which current or voltage may vary continuously with time to correspond to the information being represented. Analog circuitry is constructed from two fundamental building blocks, series and parallel circuits. In a series circuit, the same current passes through a series of components. A string of Christmas lights is a good example of a series circuit. If one goes out, they all do. In a parallel circuit, all the components are connected to the same voltage, and the current divides between the various components according to their resistance. A simple schematic showing wires, a resistor, and aperture. The basic components of analog circuits are wires, resistors, capacitors, inductors, diodes, and transistors. Analog circuits are very commonly represented in schematic diagrams, in which wires are shown as lines, and each component has a unique symbol. Analog circuit analysis employs Kirchhoff's circuit laws. All the currents at a node, a place where wires meet, and the voltage around a closed loop of wires is zero. Wires are usually treated as ideal zero voltage interconnections. Any resistance or reactance is captured by explicitly adding a parasitic element such as a discrete resistor or inductor. Active components such as transistors are often treated as controlled current or voltage sources. For example, a field effect transistor can be modeled as a current source from the source to the drain, with the current controlled by the gate source voltage. When the circuit size is comparable to a wavelength of the relevant signal frequency, a more sophisticated approach must be used, the distributed element model. Wires are treated as transmission lines, with nominally constant characteristic impedance, and the impedances at the start and end determine transmitted and reflected waves on the line. Circuits designed according to this approach are distributed element circuits. Such considerations typically become important for circuit boards at frequencies above a gigahertz. Integrated circuits are smaller and can be treated as lumped elements for frequencies less than 10 GHz or so. Digital circuits. In digital electronic circuits, electric signals take on discrete values to represent logical and numeric values. For these values represent the information that is being processed. In the vast majority of cases, binary encoding is used. One voltage, typically the more positive value, represents a binary 1, and another voltage, usually a value near the ground potential, 0V, represents a binary 0. Digital circuits make intensive use of transistors, interconnected to create logic gates that provide the functions of Boolean logic and NAND, or NOR, XOR, and combinations thereof. Transistors interconnected so as to provide positive feedback are used as latches and flip-flops. Circuits that have two or more metastable states, and remain in one of these states until changed by an external input. Digital circuits therefore can provide logic and memory, enabling them to perform arbitrary computational functions. Memory based on flip-flops is known as static random access memory, SRAM. Memory based on the storage of charge in a capacitor, dynamic random access memory, DRAM, is also widely used. The design process for digital circuits is fundamentally different from the process for analog circuits. Each logic gate regenerates the binary signal, so the designer need not account for distortion, gain control, offset voltages, and other concerns faced in an analog design. As a consequence, extremely complex digital circuits, with billions of logic elements integrated on a single silicon chip, can be fabricated at low cost. Such digital integrated circuits are ubiquitous in modern electronic devices, such as calculators, mobile phone handsets, and computers. As digital circuits become more complex, issues of time delay, logic races, power dissipation, non-ideal switching, on-chip and inter-chip loading, and leakage currents become limitations to circuit density, speed and performance. Digital circuitry